Assalamualaikum and hello everyone. Welcome to the video for 3.1 Galvanic cell. In this video, we will learn to express half cell equation and the overall cell reaction equation and illustrate a galvanic cell using a cell notation. On your notes, it will be on page 3. So what is actually a cell notation? It is a shorthand way of expressing a reaction in an electrochemical cell. So to write down cell notation, there are some requirements and the characteristic to write down the cell notation itself. Okay, so the first one, you have to draw one line to represent phase boundary. So what does it mean? Okay, if you have two species, nickel solid and still nickel, but then nickel 2 plus aqueous. So what you have to draw is actually because we have two different phase. One is solid, one is aqueous, so you have to draw a line here. Okay, but then the second one, okay, two lines represent a salt bridge. Okay, so for example, and then we have, for example, here you have your copper. Okay, but then you have your salt bridge first, so you have to draw two lines. Okay, the third one, reaction at anode will be on the left, while the reaction at cathode will be on the right. So that's why, okay, for the cell notation, it follows the ABC rule. A stands for anode, B stands for bridge, C stands for cathode. Bukan ais batu campur, the anode, bridge, cathode. Okay? Okay. Next, we will use a comma for components that are in the same phase. Okay, so if we have different phase, we will use a line. Okay, for example, here we have the same phase, aqueous. So we will use comma. Okay. Next, we have to indicate the phase concentration and pressure if given in the cell notation. So phase usually we will include it, concentration and pressure if given based upon the question itself. Okay, next, we don't have to include the stoichiometry in the cell notation. So that are some of the rules. Okay, based upon here, please write down all your notes as well. For the ABC rule, we will start and end with solid. Okay, solid will be our electrode lah. Okay, so let's look for the examples first. Okay, for the first one, we will look for the case of active electrode. Okay, active electrode means that the electrode is involved in the half cell reaction. Okay, so for example, here we have our zinc. Our electrode is zinc, and zinc is involved in the reaction itself, where it will lose two electrons. Okay, so from the cell notation, okay, we will follow the equation itself. It started with zinc solid, so we will start with zinc solid, and then we have zinc 2 plus aqueous. Do we have to include the electron? Okay, there's no need to include the electron because actually for the cell notation itself is about our anode and cathode, where the electron itself will be cancelled out, so the electron will not be included in the cell notation, no electron. Okay, so what we have here, okay, remember the reaction must start and end with a solid. So for example, here is my anode. Okay, so the starting is my solid. So because we have two different phase, so we have to draw the line. Okay, number 2 is inactive electrode, where the electrode is not involved in the half cell reaction. Okay, in this case, we have our platinum solid. Okay, platinum is an example of inert electrode, which is not involved in the reaction. When we look at the equation itself, okay, ferrum aqueous, and we have ferrum 2 plus aqueous. The platinum is not involved. We don't have any platinum on the product or on the reactant side itself. So it means that it is not involved. Okay, so how do we write it down? Okay, first I'm going to write down the ferrum 3 plus. Okay, ferrum 3 plus aqueous. And then we have ferrum 2 plus aqueous. Okay, since it has the same phase, okay, what we have to write down is comma. So we're just going to use a comma. Remember the line just to show the phase if it has different phase. Here because it has the same phase aqueous, so we will just write comma. Okay, but then actually for the half cell, start and end with solid too, just to show that it must start and end with your electrode. So your electrode must involve in the cell notation. So in this case, the electrode is platinum. So I'm just gonna write down platinum here. Platinum solid. Platinum is PT. So platinum solid here. But then since platinum solid, Okay, the next species is Fe3+, which is aqueous. So you have to draw one line because it has different phase. Okay, so that's for the second one. Okay, the last one we will look here is where the electrode will involve the gas. So in this case, the gas is H2, but then the the electrode is still platinum. So what should we write down? Okay, first and foremost, write down first the equation. Okay, first we have our H2 gas. Okay, and then we have H plus equals. Okay, the electron is not involved. You don't have to write down in the cell notation. Okay, but then here we have 2. Do we have to include 2 as well? Okay, remember, do not include the stoichiometry in the cell notation. Okay, so here, I'm just going to write down H plus equals. Okay, so here, because we have 2 different phase, so I'm just going to draw a line here. Okay, and then remember that start and end with your solid 2 must be your electrode lah. So in this case, your electrode is still your platinum solid. Okay, so here, platinum solid, and then since this one has 2 different phases, so we have to draw a line here. Okay, so that is for the general one. Okay, usually for this one, it's actually where the case where I've drawn for the case of anode. Okay, for next example, it's actually where we combine the anode and cathode from the equation, then we will draw the cell notation. So let's start with example A here. So for example A, we have our copper at anode and argentum at cathode. Okay, so I'm just going to label all the anode bridge cathode. Okay, and then I'm going to copy paste at the end here the acronym that you have to remember for the chapter 3. Okay, at anode we have copper, and remember oxidation is losing electron. So we have to write down the equation where the copper will lose electron. Okay, once I have written down the equation, make sure the atom is balanced as well as the charge. So when we check the charge is balanced, so we can proceed with cathode. Okay, so for the cathode itself, the cathode we have our argentum. So for the reduction process, it's a gain of electron. Okay, so for gain electron, just write down plus electron, okay, to form Ag plus equals. So how do I get Ag plus? It's actually based upon the electrolyte there. Okay, so when we check the argentum is balanced, but however the charge is not balanced. So what should we do? We have to sort the position. Okay, why? So when you sort the position, when you check it again, what you have is actually a balanced equation with a balanced charge and balanced atom. Okay, so that is the equation. Now we can write down the cell notation. Okay, so start with our anode. So we have our copper solid and copper 2+. Okay, but then from here we have the concentration is 1 molar. So we have to include the concentration if given. Okay, since it has different phase, we have to write down the line. So that's for anode. Okay, for bridge, it's only you have to draw the 2 lines. Last but not least is the cathode. Cathode Ag plus equals. Again, the concentration is given, so we have to include 1 molar. And argentum solid, silver solid, so Ag solid. So when we check the phase is different, so we have to draw the line. Okay, so that is the cell notation for example A. When we combine it, remember that for the start and end must be solid, and the concentration is written down if given. So for extra exercise, so let's do overall equation for this reaction. For the overall one, we have to simplify the electron. Since the electron is different, so we have to multiply all of it by 2 for the cathode. So we can simplify the equation. So right now, okay, as we check here, the electron can be simplified. So what I have to do is actually, I have to combine all the equation on the reactant side. The product must be on the product side. Okay, so here, even though from the overall we have stoichiometry, but for the cell notation, we don't have to include the stoichiometry. Again, cell notation do not include the stoichiometry, but start and end with solid. Okay, so example B, you could try yourself. Next for example C. So for example C, here we have anode, bridge, and cathode. Okay, again, I'm just going to copy paste at the side here. Okay, so at anode, we have our hydrogen gas. Okay, hydrogen gas, but then it will lose the electron. So we draw the arrow here, plus electron. Okay, but how do I get the product is H plus equals? Okay, because HCl is H plus Cl minus, so H plus lah. Okay, so when we check here, the hydrogen is not balanced. Okay, balance the hydrogen first. Okay, and then when you check here, the electron is not balanced. Okay, so when you check the charge, it's balanced, we can proceed with cathode. So cathode, we have our copper. Okay, remember it's gaining electron, so the copper must plus electron. Okay, if you're unsure, just write down the solid first, then we check whether it's correct when we check the charge itself. So copper is balanced. Okay, but then here when we calculate the charge, what we have a -2 on the reactant, +2 on the product side. So when it's not balanced, when you swap the position, okay, and then you check it again, here you have +2, -2, 0. Here you have 0. So that is the correct equation for cathode. Okay, next is the ABC rule, the cell notation. Start with our anode, which started with our hydrogen gas. But here we have our pressure. So when we have our pressure, we have to include the 1 atm. So, and then we have our H plus equals, and then the pressure is 1 molar. Again, stoichiometry is not included. Okay, since it has different phase, so we have to draw the phase boundary. Okay, so that is for the A. Next is for the bridge. So we have to draw the true line. Last but not least is the cathode. So Cu2 plus again, the concentration is given to be 1 molar, and then it will become copper solid. So that is actually the cell notation. But then when we check it again, remember it will start and end with solid. But then here is hydrogen gas. Okay, how? Actually for hydrogen, we have our platinum solid, our inert electron. Example number 3 tadi tu. At the start kita belajar. So we have to include Pt solid, but since it has different phase, we have to include phase boundary. Okay, so again, remember you don't have to include the stoichiometry. Okay, so for example D, I believe you could try it yourself. So that's it for this video.